Hey everybody, this is our toolkit for our unit on volume. Hopefully most of this stuff is review for you that you've seen previously, but we've done a nice little different spin on it, so hopefully this will help kind of summarize some of those big ideas. So we looked at a few different things. First we looked at prisms and cylinders. And these prisms and cylinders, they could be either oblique or right prisms, right cylinders. Oblique just means that they're kind of skewed or tilted a little bit. Right means the ones that we generally think of when we think of a prism or a cylinder. So we came up with a formula that is volume is equal to the big B times h, or base times height. And in this situation, we're saying B is the area of the base. Okay, so the area of the base times the height. And we have to be specific about this, that the base is opposite parallel ends of your prism. So they have to be parallel, they have to be opposite ends, and that's how you'll know what your base is. Now when we look at different types of prisms, you might see that there could be a couple different potential bases, but you really have to look at either how the prism is set up or what information you're given to determine what is your base. And then the h is just the height of the prism or the cylinder, whichever the case might be. Alright, so here's a few examples. So let's start with a rectangular prism. In this case, these would be the bases. Now you could have the other sides be bases, but generally we pick the top and the bottom if that's the option. And this would be our height. So we'd find the area of the blue bases, multiply it by the height, and we would be good to go. Or if we had a triangular prism, again, here is our bases, and this would then be our height here, because the triangles are the parallel sides. The other sides, while they would be really easy to calculate, they're not going to be parallel to each other, so that's not going to be our base. Here's an oblique cylinder where we have parallel bases here, and our height now, this is going to be outside of the cylinder. So the oblique one, you kind of have to determine the height as if you were measuring it from a tabletop to the top of the prism or the cylinder. So our height would be determined on the outside. So if you're given that slant height, you might have to use some Pythagorean theorem to get to that the height of that prism. And the last one I'm going to look at for these is the trapezoidal prism. So here the front would be the base and the back would be the base, because those would be parallel to each other. And in this case, we're actually going to have two heights. We're going to have a height inside here, and we're going to have a height outside here. Now I color-coded them slightly different, so that way we can see what happens when we start looking at the formulas across the board. So going back to our rectangular prism, we have our B, our big B, the area of the base, whatever that is going to be length times width. So that's just the basic area for a square or a rectangle. For the triangular prism, our base is, the area of the base is going to be equal to, well, we first have to find the height of the triangle, the base triangle, not the height of the prism, the height of the base triangle. So that would be 1/2 base times the height of that triangle. So make sure that you don't get that height confused with the red height here, which is the height of the prism. So the purple h here is the height of the base. Okay, for the oblique cylinder, our base is a circle, so that's going to be pi r squared. I know it looks kind of elliptical here, but these are generally circles if it's a cylinder. And then for our trapezoidal prism, now we see that the trapezoid is the basis, because that's where the two parallel sides are. And this is a formula you're going to need to know, and it's probably the hardest one out of all these to keep track of. That's the average of the bases, so the top of the trapezoid and the bottom of the trapezoid, that's what B1 and B2 are, times the height of the trapezoid. So that's going to be the area of the base, the blue part, and then you would multiply that by the red h to find the volume of the whole trapezoidal prism. Okay, so that was the first set that we looked at. Then we also looked at cones and pyramids. And we found through our investigation that the volume is equal to 1/3 times the base times the height. So if we had in this case, the B and the H is the same as the above, where the B is the area of the base and the height is the height of the cone or the pyramid. Okay, so let's look at a cone. So here is our base. So we have to find the area of that base, and then we'd also have to find the height of the cone. So however that's labeled for you. So our base here is going to be pi r squared because that's a circle. So the base times the height times 1/3. So that's going to be the volume of the cone. A pyramid, we have one that might look like this. This is a square pyramid. You could have a triangular pyramid as well, where the base is a triangle instead of a square. This one I've drawn has a square as our base. So here and the height is going to be from the base to the peak of the pyramid. So our base is going to be length times width. If it was a triangular based pyramid, it'd be 1/2 length times width, or 1/2 base times height. And then of course we're going to multiply by the height of the pyramid and 1/3. So you just kind of apply that formula, volume equals 1/3 base times height. And then just fill in the other information as needed. The third piece we looked at as far as shapes go were spheres. And spheres have a formula for the volume of 4/3 pi r cubed. So this one is a little different than all the rest because the sphere is slightly different than all the rest. So this one is we just need to determine whatever the radius is and plug into the formula. Nice and easy. Now sometimes you're presented with hemispheres. So just remember that hemispheres are half of a sphere. So you can kind of think of that as like the globe or the earth. We've got the northern hemisphere and the southern hemisphere. So that's cutting the kind of the earth in half. So that's how I tend to think of hemispheres. So it's going to be half of that. So you just take that 4/3 pi r cubed, divide it by 2, or multiply it by 1/2, and you've got the volume of the hemisphere. All right, and the last thing that we looked at we call similar solids. And what similar solids are essentially when we take and we enlarge or shrink a solid by a scale factor. So what that means is if we have the dimensions of some shape, if they have a ratio of 1 to k, then the volume of the volume ratio is 1 to k cubed. So what does that mean? Well, let's look at an example and see if we can break this out. I don't have any space to draw in here, so we're just going to look at and kind of talk about an example real quick. So the example, a prism has a volume of 356 centimeters cubed and is enlarged by a scale factor of 4. So we want to find the new volume. Okay, so what we know is 4 is that scale factor, and that represents the k in the dimensions. So if we look at our original prism and consider that our base dimensions, or not, maybe not base, but our beginning dimensions, maybe that's a better way to put it. And so we consider those dimensions a value of 1 for each one. Then k means that we're going to be multiplying each of those different dimensions by 4. So when we do that, that means that our volume is going to be increased by a ratio of k to the 3rd power, because we've multiplied each of the different dimensions by k. So we're multiplying the whole volume by k cubed. And that's really all it boils down to, is that we could take 356 and multiply it by 4 cubed, and we get our new volume of 22,784 centimeters cubed. Now we could take the centimeters cubed, or we could take the new volume and the old volume. We could find out what the scale factor is by working backwards and taking the cubed root. You could do various things for any of these problems based on the given information, and you can solve for the other parts. But this is the general overview of what we did, or what we were getting through with our investigation on volume. Hopefully this helps summarize some of those ideas, and I'll talk to you in the next video, or the next video toolkit. Peace out.